Hi, I'm Ethan, this is Devon, and we're in Team Juliet. We've chosen to focus our group project on the automation of greenhouses. We've done so because a lot of resources are wasted in many greenhouses unnecessarily, and our system would prevent this by monitoring humidity, temperature, light, and stabilizing each variable at the optimal level. Some examples of this would be that if plants are kept at a temperature which is too high, they will not grow properly, if at all, and may die. Too low and the same effect will occur. If a greenhouse is not provided with sufficient air circulation, it may get too humid, and from research we have done, we have found that mold can start to grow within plants, which may cause diseases. Too dry, and the plant growth would be hindered. Obviously, this would cause a large amount of waste, and if it occurred worldwide, so even by implementing this functionality in a small number of greenhouses, we would still be preventing a lot of waste.
In regards to the system, we took few points in consideration. So for instance, if it does become too humid in the greenhouse, a servo motor will turn on in theory and open a window. This would actively reduce waste by preventing plants from getting too humid and in turn drying and causing waste. Additionally, if the temperature reaches a value which is dangerous for the plants, a fan could turn on. However, the prototype we have represented said fan with a white light. Given more time with Arduino Uno, we would have been able to implement the stepper motor using the external power supply board. However, this was our first time using Arduino, so we weren't exactly adventurous with our attempts. Finally, in the light levels, should the light levels be too low for 12 hours, the grow lamps would power on and provide light to the plants. We were unable to implement this in the time given, however. Should the deadline be pushed back, we could have potentially achieved something like this.
Alright, thanks guys. By rubbing the DHT, the humidity is increased to above 50%, and so the servo motor will turn on.
Can you see the display from there?
Yeah.
Okay, just making sure, so they know that's what's causing it.
It's still up at fucking 56. Come on, drop. There we go. The white LED will turn off once the temperature is equal to or below 22 degrees.
Hello, I'm Cameron Janda.
And I'm Chris Lane.
And we are Team 11 at the ASU Devils event. We are teamed up with Team Juliet over at the QUB. We decided to supplement their current prototype of humidity and temperature gauging with a lighting control system. Essentially, we want to control how much light each plant will get in the greenhouse.
This is very important because every plant has a specific amount of light it needs to optimally grow. And also, it's an added benefit that every plant can never get too much light. So the system basically will use heating lamps to supplement UV rays from the sun in order to help create photosynthesis through the plants to make them grow better and stronger, because usually it's darker when seedlings are sprouting, and if it's too dark for them to grow properly, their stems become brittle and unusable and they die off. And so our project will generally help make it so less plants die and less waste is produced from greenhouse growing.
Okay, here's our current prototype. Over here is the LCD, which just reads out the temperature and humidity from our humidity and temperature gauge over here, our DHT. Over here is the portion that we added with the lighting system. Over here we have a photocell, which basically changes its resistance based on how much light there is. So if I cover it up, there's a green indicator that will flash a little bit, but what we're focusing on is this red LED over here. Right there it lit up because there's no light transferring to it. If I take it off, it'll go back towards a certain threshold. Once it passes that threshold, the light should turn off like that. So basically, we can send that information into our IoT and adjust the lighting accordingly.
Okay.